So today we're going to start with portfolio theory and the expected return. In this case, we have a portfolio of three assets with a value of 5 million, 8 million, and 4 million respectively. That should be 4 million. And then there's a cash return that's expected on each of those. So let's start by just capturing all that information into a table. So we have three investments. We'll call them A, B, and C for simplicity. And their value in the portfolio at the moment is 5 million, 8 million, and 4 million, and that gives a total of 17 million altogether. The return on that in cash for asset A is 450,000, B is 1.1 million, and C is 200,000. And so if we divide the return by the value, we can get a percentage value of the return for each of those, which works out at 9, 13.75, and 5 respectively. We can then take the cash values and divide it by the 17 million. So 5 divided by 17 gives 0.294, and you do the rest for the others. If you then multiply those proportions across by the return, that will give you the expected return of the portfolio. Next thing, standard deviation and variance of a portfolio. So in this case, we have a 2-asset portfolio. We have a probability of different types of returns broken down to best case, worst case, and most likely. And so we're going to work out the variance and then the standard deviation of each one of those. And that's given by the formulas shown here. So for the first asset, again, it's best, worst, and most likely. So those are our three possible outcomes. The probability of each of those is 0.15, 0.23, 0.62. We then have a return in percentage terms for each of those. Then multiplying each return by its probability, we get its contribution to the overall expected return, which is 13.3. Subtract the 13.3 from the 17, the 9, and the 14, and then square those figures, and you've almost got the formula complete. The last step is to multiply each of those by the probability of their recurrence, and you end up with the following figures: 2.054, 4.253, and finally 0.304. Add all of those up, and that tells us that the variance is 6.61, and therefore the standard deviation is 2.57. We now have to do the same for the second asset. The scenario is the exact same: best, worst, and most likely. We have a probability again of occurrences. In this case, it's 0.2, 0.3, and 0.5. The returns projected are 15, -3, and 11% respectively. Expected return, multiply one by the other, you get 3, -0.9, and 5.5, which gives you 7.6 overall. Subtract that 7.6 from each of the original returns, and you end up with a set of figures, and then square them, and then finally multiply that by the probability, and that gives you, for each of your possibilities, it gives you a figure. Add the three of those up, and that gives you the variance. We're now going to calculate the standard deviation of a 2-asset portfolio, and that's going to be calculated using the equation that's provided in the question, which is the weighting of the first asset squared multiplied by the variance of the first asset, weighting the second asset squared by the variance of the second asset by 2 times the weighting of asset A by the weighting of asset B, by the correlation of assets A and B, and then the standard deviation of assets A and B. So it's long, but you can work it out step by step. In this example, we're told that the value of the content of the portfolio is 1.2 million and 3 million, which means we have a 4.2 million value overall. If you divide that 4.2 into each of the contributing amounts, it tells you what the weighting is, and it's about 28.6% to 71.4. Square those, and you get the figures you have there. So now we can take each part of that formula and work it out. So for the first part, we have 0.54. For the second figure, we get 37.883. And for the third part, we slot in each of those figures. This is a big long one. And when we work all of those out, we get a figure of 6.868. So by adding those three figures up together, you're going to get the variance of this particular asset, and then by getting the square root of that figure, you're going to end up getting the standard deviation. The next thing we're going to look at is covariance and correlation. And this is about the relationship between two assets. So the first test is the covariance, which is to work out whether or not these assets move in line with each other. And that's given by the formula shown on screen. So for each day in this example, we're first going to get the observed value or the projected value, which is 10.5, 10.6, 10.4, and 10.4. From that, we can work out what the mean or average is, and it's 10.48. So what we do for each of those then is we subtract them from the observed value, and that gives us a resultant net value. And so that gives us the first part of our equation. We're going to do the exact same thing for the second observed value. So add the four values up, get a sum total of them, 57. The number of occurrences is 4, which means y bar is going to be 14.13. Subtract y bar from each observation of y, and again you end up with that final part of the formula. So multiplying the two of those together, then we get the product of each of those. So 0.004, 0.47 minus 0.043 and 0.084. And so once we've added all of those up and we have those values, what we need to do then is divide that by n minus 1. So we take that value and write it down in here, 0.0925 divided by 4 minus 1, which is 3. And that gives us a final value then of 0.03083, which, as it's a positive result, the implication there is that the assets move together. Okay, so in terms of the correlation then, that is the covariance divided by the standard deviation of the first asset and the standard deviation of the second asset. And so we can just work out the standard deviation of the second asset and the first asset by multiplying the already calculated xi minus x bar and yi minus y bar by squaring them, dividing them by 4, and then getting the square root. We have the standard deviation. So we'll do that for I minus x bar squared first, and we get the sum of it. We can get the square root in a minute. Then we'll do the exact same thing on this for yi minus y bar. So we've already calculated each of yi minus y bar, and therefore all we need to do at this point is square each one of them, which is what we're doing now. And then once we have the square of those, we add them up, and then that will give us the first part of the formula that we're trying to calculate to get the standard deviation. So to get the standard deviation, we slot them into the formula, and we end up with a standard deviation of 0.083 for x and 0.0665 for y. And so we're at the last stage here. So the formula is the covariance divided by the standard deviation of x multiplied by the standard deviation of y. And when we calculate that, we get 0.559. And the lower correlation lowers the portfolio risk while not affecting the expected returns in this case.